Well, it's a beautiful Florida day today, so let's stay inside and solder some heater meter. This is the 4.3 heater meter baseboard. You notice that it has the thermocouple option here. It's attached, it's already installed. The thermistor is the same pretty much. We'll cover the differences as we go. All right, so let's get started. So this is the top side of the board that you'll have when it's assembled, but all the components, with the exception of two, will go on the other side. Again, we're going to follow the convention that wherever the silk screen is, that's where the component goes. You notice that there's no silk screens on this side, so therefore everything must go on this side. All right, so we're going to start with our horizontally mounted resistors. These are just, your standard resistors. We're going to fold them the same way we do on the LCD board, where we just take them and bend the leads down like that, and put them into place. And we'll just start this. Just drop it into place there. Oops. Not off to a good start, are we? Oh, I forgot to wear my goggles so I can see. Soldering iron is nice and hot at 330 degrees Celsius. Let me just touch this. I'll do another one. The 1K resistors, which are brown, black, red. And again, we're going to start if there's two pads that have that we're going to be soldering, and one has this little sort of plus symbol on it. It indicates it's connected to the ground plane. It'll be a little bit harder to solder than the other one. Take a little bit more heat just to get it to flow. So that's why we'll solder the other one first, make it a little bit more stable for when we solder the more difficult pad. Just clip our parts off, and we're rolling. Let's see, I think I have another 1K. Yes, so there's 3 1K resistors on here. I'll fix the focus. I'm wondering if it may not be better to have it autofocus. We'll have to see what the final product looks like. Alright, so there's our 3 1K ohm resistors. Move along. We have one 2.2K ohm resistor. 2.2K ohms is red, red, red. There's also a gold band on there. I don't mention the gold band. It's common to all the resistors that I'll be soldering today. It just indicates the tolerance of the resistor. All right, what else we got? It's a 10K. Trying to go in order here. 10K is a blue resistor because it's metal film. It's a lower tolerance, or higher tolerance, I guess, 1% tolerance as opposed to 10% on the others. Doesn't really make that much difference, but why not? This is the reset resistor. Pulls up the reset line on the microcontroller. That's that one. Move on to the next one. This is 22K ohms. Yes. 22K is red, red, orange. It's just like the 2.2K, except for the third band is orange instead of red. You notice I just got a plus sign, so we'll just go to this one. Try to hold my soldering iron against the pad itself and then touch it to the component lead. It guarantees that I'm heating not just the lead but the actual circuit board itself, which is going to allow the solder to bond to that part. Next one, 68K. It's just one of these. 68K, blue, gray, orange. Just right next to. And we're not going to use all our resistors in this step of putting down all these horizontal resistors. There's a couple other ones, or a few other ones that we'll be doing later, but they stick up a little higher off the board. The whole idea of how we assemble this in this order is we take our components that are flattest, like the lowest to the board, and we kind of work our way up. That way when you flip it over like this and you try to solder it, it's not like all wobbly and whatnot. So we'll try to put all our components down in this order. We have a 100K. This will be the last one, I believe. It's more interesting if I do it on camera than in my lap. You can see when I push it down, it holds the component against the board. It doesn't try to slide out on me because it's all the same height. I could use more solder, but we'll get back to it. The idea being that we get these nice little solder blobs that are all nice and flat, or tinted sort of. Shouldn't look like a ball attached to the lead, because that means it just didn't get hot enough. All right, so there's all the resistors that we're going to be using in this step. So let's move along. The next thing we're going to do is these ceramic capacitors. It's these little yellow deals here. They're not polarized. The resistors aren't polarized either. It doesn't matter what direction you put them in, so you don't have to match which way they go. Same thing with these little capacitors. You just drop them into these slots here, labeled 0.1U. Oops. Say nothing falls out. I'll just kind of leave these leads as I go, because it goes a little bit faster if you don't trim the leads on every time. It's a little speed tip, but you don't want to have so many leads sticking out that it gets in your way. It makes it hard to solder. Just gonna find that happy middle ground. Now all these down here, they're all 0.1U, but there's not enough space for me to put all the silkscreen in there. So each one of these in this block is another one of these 0.1 microfarad capacitors. Pretty exciting stuff. Oh, now you see here, I kind of lifted the board as I got away from it, and that one's a little bit higher than the rest. So what we're gonna do, use our trick of just pushing your thumb against it and heat it up, and then it'll just pop into place there. There you go. Now it's the same height as the rest of them. It's a little easier because I didn't solder that second leg yet. one of these guys. This guy's got some crazy legs on him. Just a little tough to get in the hole. We'll just edit this out in post. Make it seem like I got it in first try. You might notice that before I solder, I kind of push down on the board with my hands like this, just to make sure that the component is pressed tightly against the other side of the board, and then use my fingers to stabilize it while I'm moving between it so it doesn't teeter-totter around. Yeah. And moving right along. Footloose and fancy free. Alright, so we've got this now forest of pokey pins sticking up. Always remember on these parts, you want to put your finger kind of on top of the lead, so when you snap it off like that, it has a tendency to go flying off, so you're going to want to keep it from going into your eye or finding its way into a more dangerous place. Alright. It looks like the temperature's a little hot, so we're going to take it down just a bit. That flux there. This is a Kester 6040 solder. And we got one more of those right over here. Getting this one pretty easily here. All right, for those of you rejoining us after you may have noticed a cut in the video, my soldering iron decided to stop heating. Just sort of turn itself off after I changed the temperature. Alright, get these out of the way. Alright, so now our ceramic capacitors are in place. Let's move to diodes. Diodes, now, this is our first item that has polarity. They're both the same. It's two of the same thing. You'll notice that it has on there this little band on this one side that indicates that that's the direction that's positive. And on the board, or it's the anode side, we also have a little band there as well. Makes it really easy. I'm just going to bend our leads again. Yep, I told myself I wouldn't make noise, but I'm doing it anyway. Just push it down. This takes a little bit more soldering power because the leads are a little bit thicker. See, when it wants to flip out, I kind of use my finger to hold the board down. Keep it from rolling. It's a lot easier if you're not trying to chase the board across your workbench. Hop. Ho, ho, ho. This one goes down here. Okay, so our 2 diodes in place and ready to go. Moving through the steps quickly now. Alright, so now we're going to flip over to the other side. There's 2 components that are installed on this side, which are just the risers that take it up to the button board. And they're easier to solder when there's nothing around them here. So we're going to do them now rather than before we populate all these guys down here. So let's get these out. A couple of these guys. Alright, so I put one in, and you see it's probably a little off center there. It doesn't matter too much because it can bend a little bit. What we'll do is we'll take this and we'll just kind of heat it up and just use our thumb on the back side to straighten it out, and then go too much the other direction. There we go. And there we go. Well, it's hard to tell, but it is. I swear to you, it's better. I'll just hit the rest of these now. It's the whole solder one leg and then do the rest trick. And we'll do the other one. Now again, note that these are going on the top side, not the bottom side. Again, crooked as always, so we'll just go ahead and fix that. And even better on this one, you notice I've got it slightly higher on one side than the other side. I don't want to mess with the focus, but let's see if we do it this way. Yeah, you see that I got this side over here, it's higher than this side, because I am a professional. So what I'll do is just to fix that is, just when I put it down, I'll push it down a little bit when I solder it, just to make sure that it flattens out. And there we go. Nice and flat now. About up there. And then we'll fill in the rest of this solder. Okay, moving right along. There's our top bits. Now we're done on that side. I'll go back to this guy. Alright, power Mosfet. Looks like this little guy here. It's the only one that's in the box. Can't go wrong. Just stick it down in the thing and then pull it up a little bit, just so it sticks up above the board, and then just bend it down. And kind of jockey it around a little bit to make sure that it lays flat. Somewhat flat. Just kind of push these legs so they're, straight up and down. Flip it around there. There they are, straight up and down. Oh. Alright, let's solder. You see we're getting a little close on this side here. Try not to melt our connector. Let's verify that. Oh, it's popped up a little bit on us. There we go. Ooh, gets hot quick. Alright. It's a little crooked, but it doesn't matter as long as it stays inside the the green there, rather than gets into this cutout area. You shouldn't have a problem. This part you probably don't need. Hang on, let me cut this lid. Okay. You don't need this part really. Adds a little heat sinking. If you attach the Mosfet to the board here, what I do is use the point, sort of point of my tip here, and just push it up underneath there. Wait for it to get hot. by applying the solder to the other to the part underneath there, not actually to the soldering iron itself, and then just wait till it flows up onto the Mosfet. And that's all there is to it. Oh, it's really lovely angle there. You can see that the solder is nice and flowing across the top there. Alright, 20 pin dip socket. Here's our dip socket for holding the microcontroller. It's got a small indentation on one side here. It's really hard to make out on the white there. Yeah, you can kind of see it there. It's on this side here. It's on the side that says 28, not the side that says P. We'll flip that over and we'll use that, match that up with this indentation here. Start with the reset and the LE1 pins down here. And then hold it from behind. Push it in and touch the solder again. Alright, and then now it should be straight. Yeah, that looks pretty perfect. And then go back and solder up all your other joints. Ground pin takes a little bit more effort there, as you can see, and zip through these other ones. The ground one just takes a little bit longer to the solder to spill over. Alright, so that. Alright, then we need a power supply. Uh-oh, I don't have one. Alright. This is our step-down regulator. Takes the voltage down from 5 volts to, or from 12 volts to 3 volts, or 5 volts. 12 volts to 5 volts. Now you can just read the pins here and it'll tell you what I'm actually doing. The circuit board knows better than I do. So we're just gonna kind of hold it with our thumb there, just straighten it out a bit. Okay, finish it up. Looks good, looks nice and close as we can get it there to the circuit board. And our speaker. We'll cut these, just cut this bottom part off. Drop it on in the speaker hole. Bit of trivial knowledge, the tone emitted by HeaterMeter when it sounds its alarm, well, let's see, we did a great job of not getting that level. When it sounds its alarm is 4 kilohertz. 4 kilohertz was chosen because this piezo speaker has its highest volume at 4 kilohertz, so I just coded it to generate a 4 kilohertz tone. And there we go. Speaker's on board. Alright. Now we're going to get to the little water tower components. We have 2 different kinds here, so be careful when you pick these out. The ones that we're going to be going with first are the BS170. It's got a little F icon at the top, the logo for Fairchild Semiconductor. BS170. Do not mix up this one with the MCP 1702. And what we'll do is I'll just bend this leg back, the center leg back straight, like that. And I'll grab it with my needle nose pliers. And then just kind of fold it over. I did a terrible job. Let's do that again. Just fold it over. Like that. There we go. Done that 100 times, and of course I mess it up the worst when people are watching. Oh, that's out of the way. That's straight. Yeah. These don't have to be terribly close to the board. It won't stick up that much that anything will ever get in their way. All right. I've got 3 of these, so you get to see if I can do it right at least 1 out of 3 times. Spin the leg back with the needle nose pliers. Just give it a little kink. Like so. Things are shiny. These all go in a row down here at the bottom. Okay, last one, bend that leg back. With the pliers, just to bend up. All right, all right, now we'll move on to the next little water tower looking guy. This looks identical, but instead the markings on this, let's say 1700 3302E. This is the 3.3 volt linear regulator. Drops the 5 volts down to 3.3 volts. We're doing the same thing where we just bend the leg back and grab it with the pliers and bend it up. You gotta be careful with these a little bit because if you're a little too excited with the bending, it's pretty easy to break the leg off. Alright, well, here's a little challenge for you guys. Soldering in there. See if I can get the best view of it. I'm gonna start with this leg out here because once that one's in place, the part won't move anymore. Move on in there. There we go. All 3 legs in there. It's difficult to choose a time when to install what component here. I mean, this definitely gets in the way. It's easy to burn it. All right. So those are all our little TO92 parts. It's the little water towers. Oh, you know what I did? I installed something at the wrong time. CC SMP. Oh, yeah. I see this piece wasn't supposed to go on until later. But you know what? It's the same height, so it doesn't really matter. The part that I was supposed to put on there is the thermocouple connector. The thermocouple connector is pretty flat, right? So it's going to go down here in this little position here. You're going to want to put that down like that. I'm going to kind of see if I can get this on camera somehow. I need something else to put under it. How do I have nothing sitting around here? I guess we'll take this. Take this piece and just put something underneath it so it holds it against the board a little straighter. Now if you're doing this, you can go and get something else to put underneath it that actually works a little bit better. Just do that one back leg here, because then we're gonna put this strap little piece across the top there. And if you solder both legs, it's hard to get it angled. So we'll just put this little bit over the top. Down. Now we don't need this anymore. Just push it against the table while you're soldering. Oh, you want two phases. Yeah. Looks good. And this one. Oops. Look what I've done. Alright, and then we'll get these two guys here. Alright, there's our thermocouple connector. Alright, on to the Raspberry Pi connector. Just drops in on this board inside. Again, the side with the white bits on there. Not this side. Even though it's got labels here, it doesn't mean to put the connector there. If you put this on the wrong side, you will be in trouble. Let's go with this. Now you notice that there is a 3.3 volt labeled pin here. So why is it? I'll push this against the table and just heat these up to make sure the component is in there well. Nice and flat. Now the reason we don't use the 3.3 volt regulator from the Pi, there's two reasons. Number one, so you can disconnect the Pi and the heater meter will still work on its own. You can run it standalone. The second reason is that the 3.3 volt regulator on the Pi is a switching regulator, which means there's a certain amount of noise to it, just because it's switching on and off all the time, a million times a second basically. So we use the linear regulator, which kind of acts as a little bit of a buffer against some of the switching noise. Gives us a little bit more accurate readings. Ground connector. I feel like this temperature is still a little high for this solder. Now when soldering, it's always nice to have a drink nearby, but let me tell you, it is dangerous. Any drink that I have that's not in a sippy cup within 10 feet of where I'm soldering will somehow get itself wrapped around the soldering iron and get knocked over. So I do not have a drink with me today. Okay, there's our Pi connectors in place. We're going to, oh, I just lost a part onto the floor. That's okay. Put this little blobby yellow-orange thing on there. It's a 16 megahertz resonator. Resonators are like crystals. They're a little less accurate, and they have a temperature. Like if the temperature changes, can cause a greater effect in their operation. for us, it really doesn't make that much difference if we're, running up to 5% slower or faster. And it takes less board space than a crystal would require. Also some biasing or resonating capacitors with it. Okay. All right, so now we'll get back to our resistors that we didn't use. We've got a few of these. We're going to start installing these. These we're going to bend a little bit more differently, biglier, because they're going to be mounted vertically. So I kind of just bend one leg over. We're going to start from the food 3 side and work our way down. Next. Goes in the food 2 hole. Good. One more. Come on, there we go. Yeah, that's the food one. Alright, now here's where the steps differ if you're doing a thermocouple board versus a thermistor board. Let me just click these leads. With the thermistor, if you have 4 thermistor probes, you're going to install one more 10K resistor. 10K resistor, if you put it in with a thermocouple board, thermocouple is not going to work right. And that position is right down here, the bottom corner. It's R18, not that it says that next to it, but it's the bottommost resistor here. And because we're doing a thermocouple board, we're just going to leave that one out. And we'll go ahead now and we'll do the 100K. You see there's a 100K position above it, but we're going to use that one, but not the 10K. We're going to do the same thing. 100K resistor, brown, black, yellow. And there's on the silk screen, there's like a little fat side for one of the resistor holes and a little thinner side for the resistor hole, but it doesn't matter which direction you put them in. It's just there to let you know that, it's part of this resistor. You can see here like these, there's a circled hole and a non-circled hole. Doesn't matter which way it goes. The idea being that the body of the resistor goes against the circled hole side. Doesn't matter though. Here's another tight one. One of these. Oh boy. Quite enough solder in there. These bent over guys. You do want to make sure that the thermocouple copper bit there does not touch the bare wire on this resistor. These two touch will not have very good working thermocouple. So I guess in that case it does matter which direction you install it. Flux is getting a little crusty in there, but that's all right. It's fine to leave on the board. We have everybody in. Everybody's, well, this guy's sticking up a little bit too high, but who cares? It's not too much that it's going to make a difference. So there's all the rest of those standing up resistors. You should only have no resistors left now, unless you're doing the thermocouple board, in which case you'll have an extra 10K resistor left over. Let's do our inductor. It's a big old inductor here. It's just a piece of wire wrapped around a little bobbin in the middle. And this has longer legs on it on one side versus the other side. Oh, we're a little crooked. Won't you go in any further? Yeah, that's weird. It's a little bendy component. One leg's longer than the other, but it's not polarized. It kind of is if you're worried about EMF, because the EMF that's generated from it actually goes in the direction of the current, right angle to the current. So I guess if you're building something that is EMF sensitive, you'd want the EMF to be pointed away from your sensitive circuitry. For us, it doesn't matter because it doesn't generate enough to actually make a difference in our noise. What's next? So now our electrolytic capacitors. These all look very similar, but the writing is here on the side that tells you what they are. This is 47 microfarad, 25 volt. Just match it up to the board. It's over here. The longer leg is the positive leg. The side with the stripe on it has the negative symbol on it. That's the negative side there. So on the boards here, it has a little plus to indicate where the positive side is. So we'll just take the longer leg and stick it in the plus side. And it goes. Straighten it out a bit. It's not really all that important to make the part straight. Just feel more professional if I do. All right, so now there'll be two of these 10 volt, 100 microfarad ones. And you'll know if you put these in backwards when you turn the device on, because if they're put in backwards, it creates a straight short right to ground. So nothing's going to work in that case. Oh, man, I can't get this pad to heat here. There we go. So your power supply will almost immediately turn off and start turning on and off. So the overcurrent protection kicks in. And again, another one of these 100 microfarad 10 volt capacitors down there. And one more big fat one. It's 25 volt, 100 microfarad. It just goes in the middle. Down there. Okay. All right, we'll do a quick visual inspection to make sure that they're all facing the right direction. The three in this group here all should have their lines facing the same direction. The negative side should be all facing the same way, and then the one up on top here is flipped around the other direction. So three facing towards the front, one facing towards the back. We're good to go there. All right, let's take it home by just putting our jacks in now. Just jack in here. Start with the power jack. And the easiest way to solder these in is kind of go for the side that's closest here, like that. Now that it's in place, we'll heat it up and just push it into place. Blow on it so it's nice and cool. Again, we'll start on the smaller side. It's hard to kind of see. There's this side that's the pin is closer to than this side, so we'll solder on this side first. Makes it easier to get it connected. This one right in the middle. Kind of drag the solder across. Now we could just do one side and it's enough of electrical connection to, you know, hold it to do its job. But this is a mechanical part. You're going to be plugging in the 12-volt adapter and unplugging it. So I like to fill up the solder holes completely, which gives it a little bit more strength in the long run. All filled in there. All right. Next, let's do that jack. That jack just goes right in here. Check to make sure I didn't bend any of the pins. It sounded like it went in a little weird. So I'm going to push this down to make sure it's fully seated. Now you may wonder why we chose an Ethernet jack, even though we're not running Ethernet through it. We did a couple different iterations on what the probe connector should be, or this output jack should be. The thing was that everybody seems to have a Ethernet cable laying around their house or something, or a phone cable, and either one you can stick in here and make it work. Phone cable will obviously just give you the 4 center pins, or 2 center pins even, depending on what type of phone cable you have. But everybody's got an Ethernet cable or a phone cable laying around, so it's something that's easy to just cut the end off of and solder your fan to. All right, now we just need our probe jacks. 3 of these. And slip those in. Put it in. Solder it up. Come on. I just kind of do one pin at a time, and then make sure once they're all in, I can go back across them all. Or one pin out of each. You can tell for sure that this one is crooked. Put that in there. Alright. Come across the back side. More solder. All right. Before I finish putting all the solder in here, I'm going to do the old thumb trick again. Just heat it up, push it in, heat it up, push it in, heat it up. And then do the fronts again. Let's make sure that they're 100% stuck up against the board. Oh, that one's not soldered very well at all. And then the last step. So we'll solder these bits in. Again, mechanical part, so I just fill in all the holes, make it as strong as possible. Although you note that I do not fill in the holes on the other one, so I guess I'm not filling in all the holes. That other pin is a brake connector, basically. That's connected when there's nothing in the jack, and I don't really use that for anything. So there you go. It's got one finished heater meter soldered. So finish up, we're going to take our AT-Mega pen and we're just kind of bend the pins in a little bit to flatten them out so they'll go in easier. And line up the notch with the notch on the device here. Notch is there, notch goes here. Now it's really easy to not get all the pins in, because they do not want to go in all together. So you really be careful here to make sure that before you push it down all the way, that all your pins on both sides, you got none sticking out and none folded over, bent in. Otherwise, could be in trouble. All right, just seat that, finish seating that, and there you go. It's one beautiful heater meter, ready to go, ready to mate with its LCD board.